Welcome everyone. In this video, we are going to learn about logarithms, law of logarithms, and change the base of logarithms. This is the learning outcome for this subtopic. Logarithms are the opposite of exponentials or indices. If a and x are the positive real numbers with x equals to a to the power of n, then log base a of x is equals to n, where x, which is called as the argument, must be a positive real numbers. We notice here that the base of the index form is the same as the base of the log, and the power of the index form is equals to the value of log. Meanwhile, the argument of the log is equals to the value of the index. We pronounce the logarithm as log base a of x equals to n. So let's do the example. We want to express this index form into log form with suitable base. For question A, 8 equals to 2 cubed. We notice here that the base is 2, so its logarithm form must be a log base 2 of 8 equals to 3. Question B is 1 over 5 to the power of negative 2 equals to 25. And the answer is log base 1 over 5 of 25 equals to negative 2. We always use the law of logarithms to simplify and solve equations involving logarithms. The three main laws are stated here. The first law is the product rule, where log base a of xy is equals to the sum of two logarithms, which is equals to log base a of x plus log base a of y. The example is log base 10 of 2 multiplied by 3, which is equals to the sum of log base 10 of 2 and log base 10 of 3. The second law is quotient rule, where log base a of x over y is equals to subtraction of two logarithms, which is log base a of x minus log base a of y. The example is log base 5 of 2 over 3, and this is equals to log base 5 of 2 minus log base 5 of 3. The third law is power rule, where log base a of x to the power of b can be written as b multiplied by log base a of x, which means we transfer the power of b to the front of the log. The example is log base 3 of 8 squared, and this is equals to 2 multiplied by log base 3 of 8. Four other important laws are stated here. The fourth law is log base a of a is equals to 1. This means when the base and the argument are the same, then it is always equals to 1. So for the example, the answer is absolutely equals to 1. The fifth law is log base a of 1 is equals to 0. This means that log of 1 to any base is always equals to 0. So the answer for the example must be equals to 0. The sixth law is log base a of a to the power of x is equals to x. This is because we can apply the power rule, where we transfer the power of x to the front of the log. Since log base a of a is equals to 1, so the answer is just x. Then for the example of log base 2 of 2 cubed, the answer is 3. The seventh law is a to the power of log base a of x is equals to x, which means when an index raised to the power of logarithm with the same base, then the answer is x, which is the argument of the log. So for the example 2 to the power of log base 2 of 3, the answer is 3. The two most common bases used for logarithms are base 10 and base e. The log with base 10 is called as common logarithms. However, it is always written without the base 10. Natural logarithms is the logarithm with base e, where e is an irrational constant and also called as exponent. Its value is approximately 2.718281828. Natural logarithms always written as ln, which read as ln, and ln e is equals to 1. So, this is the exercise. The first question is, write the following as a single logarithm. For question 1a, we use the quotient rule first because it involves subtraction of log 8 and log 6, then followed by the product rule and simplify it to get the answer. For question 1b, we use the power rule so that the coefficient of 2 raised to be the power of x plus 7. Now that both ln have no coefficient, so we can apply the quotient rule and express it in single logarithm. Question 2 is, given log 2 equals to 0.301 and log 6 is equals to 0.778, find log 12. We know that 12 is the multiplication of 2 and 6, so we write log 12 as log 2 multiplied by 6. Now, apply the product rule where we can express this into the sum of two logarithms. Then substitute log 2 and log 6 with the given value, then calculate to find the answer. For this question, it is a proving question. We must prove this logarithm equation can be expressed as this equation which has no logarithm. That means we have to eliminate the log from the first equation. To do so, we must use the law of logarithms to simplify both sides of the equation. On the left side of the equation, we apply the product rule, where the sum of log m and log n expressed as a single log mn. Meanwhile, on the right side of the equation, we apply the power rule, where the coefficient raised to be the power. By comparing both sides, we get an equation which have no logarithms. For the expression on the right side, we had to distribute the power of 2 to both numerator and denominator. Then, by expanding the numerator and squaring the denominator, we will get this new equation. Solve the equation until we can prove that it is exactly the same as stated in the question. It is important to know how to change the base of logarithms because we will apply this when simplifying or solving equations involving logarithms. Now we will learn on how to get the formula first. So, let's say we have log base a of m equals to x, where a and m are positive integer and a is not equals to 0. Then this log form can be changed to index form m equals to a to the power of x. By taking log both sides with base b, we have this equation. Then, by using the power rule, we can transfer x to the front of the log and express x as a subject. Since x is also equals to log base a of m, so they are both equals to each other. And we get this formula. To memorize this formula, we look at the position of m and a, where m is above a. We know that this is the formula to change the base of logarithm. In a special case, when we substitute m with b, the formula will become like this. We know that log base b of b is equals to 1, so we get this new formula. This means that when we want to change the base of logarithm to be the same as the argument, then the numerator must be 1. So, the example is express log base 2 of x plus log base 8 of x as single logarithm. We know that we can express the sum of two logarithms as a single logarithm when their bases are the same. So, in this question, we have log base 2 and log base 8. It is better to change log base 8 to base 2, and we get this. Then 8 can be expressed as 2 cubed, which then becomes 3. Log base 2 of x over 3 also can be written as 1 over 3 multiplied by log base 2 of x. By adding both logarithms, we get 4 over 3 multiplied by log base 2 of x. If you are wondering of how the answer becomes 4 over 3, think of log base 2 of x as another unknown, say y. So it is actually y plus 1 over 3y, which then become 4 over 3y. Please submit this exercise to your lecturer before the class ended. Thank you.